2016 paper. So this here also a vessel, and then the depth of the vessel is 12 cm, which contain milk. And then Peter further poured 444 pi cm cube into the vessel. And now he find the depth of the milk in the vessel is 16 cm. Okay, so we try to draw it out to let us understand it first. So we have a vessel, and then the milk we put in the 12 cm, and we further adding some milk. Now the total height reached 16. Okay, so actually for the height of the whole vessel, you don't know, okay? You only know what you know is the larger cone here is 16, the smaller cone have the height 12 cm. Okay, so 444 pi is about the first term. It means that the volume of the first term is 444 pi. Plus the volume of smaller cone, the smaller cone here, actually they will equal to the entire cone, okay? So the length ratio, what we have here, why we need to find the length ratio? Because it's asking volume, right? It's asking volume, but what we have is the ratio of height, So we first find the length ratio and then the volume ratio. Okay, so it's cube. And then make sure you know what is this ratio means. What is the meaning behind this ratio? This one is the smaller cone here to the largest cone, So it's not the smaller to the first term, okay? So we only have the similar shape ratio. If they are not similar, we cannot find the ratio by this way, okay? Okay, so when we have the ratio, we now know that we need to make use of the 444 provided to us, because we only have three numbers. One is the ratio 12 to 16. Another one is the volume 444 pi of the first term. Then how can we use the volume of the first term to help us find the entire cone's volume? You know that this ratio actually equals to the smaller cone. How we calculate smaller cone? We let the entire cone to be x, the volume, and then entire volume minus the volume of the first term. Here is the first term. It will equal to the smaller cone down there, right? Over the whole thing, over the entire volume of this cone here will equal to this ratio. We just write it out, and then we solve it. Cost method. And then we can have x equals to 768 pi. B, asking, Peter claimed that the final area, so now it's finding the area, of the wet surface area of the vessel is at least 800 cm square. So it means that we only need the part with milk. So we do not need to find out, and actually we cannot find out the total height of the vessel, okay? So the height here we already have is 16. And then how we find this curved surface area? We can use the pi RL. You already have the height. Actually, height is not in this formula, but you can use the height to help you find the slant height, okay? The slant height here. Can we find the radius? Because we need radius. Can we find the radius? Yes, you can. How? Because you already know the volume. Using the volume to help you find the radius. So you just put in the formula, put in the volume formula, and then 1/3 times the height times R square pi equals to the volume we found. Okay, so you find out R equals to 12. And then now you find the slant height by Pythagorean, and then time pi times the R equals to the final surface area, curved surface area, which is smaller than 800 cm square. So no, I don't agree. 2017's paper. So this year we have prism. Prism is basically base area times height. So it gives the base area to you and the height. And now it's melted and recast. So the volume stay the same. And then it's recast into two similar pyramids. So it's two different size pyramids. Be careful of that. And the base are both squares. The ratios of the base area of that two pyramids is 4 to 9. So now you have the area ratio. Find the volume of the larger pyramids. So step by step, and analyze what information we have. So first, the total volume, you have it. So you calculate the total volume first, because the volume won't change. The amount of material is still there, right? And then, now you only need to find the largest pyramids. But you now only have the total volume. How can you find the volume of the largest one using the ratio? First, area ratio is 4 to 9, and the length ratio is square root this, so 2 to 3. And then volume ratio is cube them. So 8 to 27. 8 to 27 is the smaller pyramids to larger pyramid. How to find the volume of the smaller pyramids to the largest pyramids? So we let an unknown, the unknown x be the volume of the largest pyramid, so that you can find the smaller one by using the total minus the largest one, and then over the largest one. So this one will be the smaller one, right? Smaller one over the larger one will equal to this ratio. Another method to do it, so you know that 4 plus 9 will be the total of the ratio, right? So 4 plus 9, and then 9 over 4 plus 9 means that the largest volume over the total volume times the total volume. You can directly calculate the volume of the larger pyramids as well. So it depends on which method you like, okay? Which methods you like. Okay, so this one is the ratio of the smaller one over the larger one. So you find the smaller one by using the total to minus the unknown here, okay? So cost method, you will calculate x equals to 1296 cm cubed. Okay, so part B, now telling you that the height of larger pyramid is 12 cm. It means that by giving you the height and we calculate the volume, you can find the base area. Find the total surface area of the smaller pyramids. So now we are finding the smaller pyramids. It means that we need to use ratio again, right? So total surface area, the area ratio, we already have it. So now what do we need to find? You want to find the surface area, and its pyramids, it looks like this. Pyramids have four triangle as the lateral face, and then one base square. The base square, we can calculate it. And then how about the lateral face? The four identical triangles here. So you need to find their height and the length, the side length of the square. Okay, so first step, we use the volume to help, given the height, and then we put in the volume formula. We can find the base area. As we know, it's a square. So it's a square, so we square root it. We know that the length of its base should be 18. And then the base area, we already have it. Now, you know this one is 18. You need to find the lateral face area. The lateral face area, keep in mind that it's not the height. It's not the height of the pyramids. It's different. You need to use Pythagoras here, okay? The height of the face is not the height of this pyramid. You can see here is a triangle, right? So using the triangle Pythagoras, we know that we need to find the height of the square first using Pythagoras times 18. 18 is the base times 1 over 2. This is the equation of area of triangle, right? So base times height over 2. And then we have 4 identical face. So we times 4. And then plus the base area here. Okay, after you calculate it, you have the answer. Keep in mind that this one is just finding the largest pyramids, okay? What you need to find is the smaller one. So given the area ratio in the question, we now find it through the ratio. The largest one is this one. The smaller one should be 4 over 9. So we time the ratio using the volume to time the ratio. You will directly have the smaller pyramids, the surface area of the smaller pyramids. 2018 question, you have a cylinder container and another one is the cone vessel. So given the radius and height, the container now is fully filled with water, and the water in the container now pour into the vessel. Find the volume of water. So the volume of water, because it's fully filled with water, so it equals to the volume of the container here. So we can draw out the container. This one you do not need to time 1/3. Because it's a cylinder, right? So base area times height, you have the total volume. Okay, B, find the depth of water in the vessel. So now we have that much water. We pour into the vessel here. we do not know the height. We do not know the height of the water. That's what we need to find out. But we have the entire height of this vessel, and we can find out the volume. Why we need to find out the volume? Because now you have no information of the length ratio. You have no information of the length ratio, but you can find out the volume ratio because you already have the water volume. So what you have is water volume and the volume of the entire vessel. You can find out, but the length, you don't have the smaller radius, so you don't have the length ratio. We find out the volume first, volume of the vessel. So put in the cone formula of volume, and then you have the volume ratio. This one. And then, when you have this one, you can find the length ratio for cube root. And then you have 4 to 5. 4 to 5 should be the length ratio, no matter the radius, no matter the height. So it means that you use 60 to time 4 over 5 will be the height of the water, will be the depth of the water, which equals to 48. Or you write like that's both okay. The smaller over the larger equals to 4 over 5, and then H equals to 48. In C, we have another sphere adding to the vessel, and it's totally immersed in the water, so it means that we just need to add up the volume. Will the water overflow? It means that will the water come out? Will the volume of the water plus the volume of the sphere larger than the total volume? So it means that we need to find out this one plus the volume of sphere smaller or less than the volume of the vessel, okay? Okay, so see, we'll first find the volume of the sphere first. So we have the formula here, 4 over 3 pi r cubed. And you have this one, you can write in decimal or fraction, both okay. And you can add up this one with this one, or just use the total volume to minus the water volume. The volume remaining is this one. And then you compare with the volume of sphere is larger than. So it won't overflow. Make sure you write the answer sentence, okay? Answer sentence. 2019 paper, we have the sum of the volume of two spheres is this number, and then it tells you that the radius of the largest one is equal to the diameter of the smaller one. So when you join out, one is larger, one is smaller, and let's say we let this diameter into x. So the diameter of this one, or the radius of this one, will be x, so the diameter is 2x. Okay? So actually you can see their length ratio is 1 to 2, right? It's 1 to 2. And then they add up the volume equals to this one. This year only contains 5 marks, so it means that it's relatively easy. The volume of the larger sphere, so you can do it in 2 methods. One method is using the ratio. As we say, the length ratio you first calculate it. So I use the larger to over the smaller, okay? So it's 2 to 1. And then the volume ratio will be 8 to 1. And then once you have the volume ratio, beware of it. This is the total volume. They add up, right? So you cannot use this one to times 1 over 8. That's not correct. You need to times 8 over 9. Why is 9? 9 because their 2 add up, right? The 2 add up is 9, and then 8 over 9 means that the largest one occupy 8 out of the 9 here. So times the total volume, you will have the volume of the larger sphere. So if you are not familiar with those ratios, you can do in another method. Is that when you let this one is 2x, you can directly put in the volume formula. So 4 over 3 pi x cubed. X cubed is this one because the radius, right? Radius is x. And this one 4 over 3 pi x over 2 because the diameter is x. So the radius is x over 2 cube equals to the total volume. And then you can cancel the pi first, and then move, as 4 over 3 is common factor, you take it out, move to the another side, and then here x cubed plus over 8 plus x cubed, you can take out the x cubed, and here is just a number, move to the side, divide by it, x cubed is 216, and then after you cube root it is 6. And remember that you are finding the volume of the largest one, right? So now you solve x, but but you need to continue to calculate the volume of the largest one. So you put in the volume formula, and here the radius is 6 equals to 2AA pi cm3, okay? So two methods, you can choose one. For B, find the sum of the surface area. So now we need to put in the surface area formula. So if you are using method 1, you now have the volume of the largest sphere, but actually you don't know their radius. You haven't solved it, right? So now if you are using method 1, then you use the formulas here to solve the x. Actually is what we done in the method 2, okay? So you just use the volume and solve what is x, and then put the x into the surface area formula, 4 pi r square, and the smaller one, the radius, divide by 2, and then you have the total surface area, okay? So if you are using method 2, then that will be more easy for you to do part B, because you already have x equal to 6, so you directly write this equation, then you have the full mark here. 021's question. So this year we have so many sentences here. So first we have a cylinder, and then a cone Y. So their base radius are equal, and the height given to you. And then we have another cone Z. The volume of the Z is equal to the sum of volume of x and y. So x and y plus together equals to Z, the volume, okay? And then the last sentence tells you that the volume of y is 800 pi cm cube. So 800 pi cm cube. Find the base radius of y. So we have the volume. You just need to put in the volume formula, because you have the you are finding the radius, you have the height. So that's one very easy. You can find r equals to 10. Y and z similar. So y here, z here. To check if they are similar or not, we can use two methods. One is that you check their length. All their lengths should have same ratio. So you can find out the radius, find out the height. Or you can check the ratio of radius square to check if it aligns with the ratio of volume, okay? So both methods okay. Here, I think finding height will be easier. We have the radius already, r equals to 10. So make sure you label all the information. When you calculate r equals to 10 in the graph, you need to write r equals to 10, r equals to 10, 2r equals to 20, okay? So the radius ratio should be 1 to 2. And then find out the height. How we find out the height? We have the information that the volume adding x and y equals to z, right? So z, we have the cone volume formula here. And then the y, we already have the volume, and then plus x. X is base area times height. For a cylinder, cancel the pi, and then we have this number, h equals to 21. So we check the ratio. The height of y to z, here is y to z, so put y here, z here, 24 to 21. So it's 8 to 7, not equals to 1 to 2, so not similar. Okay, so you can also do this method as well. I think finding the height is easier for me. So C, asking the sum of curved surface area of x and the curved area of y plus together should be greater than the curved surface area of z. Do you agree? So we calculate the curved surface area. Basically, you just need to remember the formula correctly. You can find out. Okay, curved surface area. For cylinder, it should be the base circumference, okay, the base circumference. So 2r pi circumference times height, okay? So remember this, finding the curved surface area for cylinder. And for cone, it should be L pi. So pi here, R here, L should be using the Pythagorean to help. So we have 10 here, 24 for the height. So Pythagorean to find the slant height. You will have 660 pi cm square. And the curved surface area of Z should be, is another cone, right? So this is radius, this is pi, this is the slant height. So using this one, Pythagorean again. So after we times it, we find out it's less than the surface area of x plus y. So we agree with the claim. Okay, 2022's question. We have two metal spheres, and now it gives the ratio of its surface area 4 to 9. So we have the one smaller, one larger sphere, and we know the area ratio is 4:9. Okay, so now the radius of the larger sphere is 9 cm. Find the volume of the smaller one. So the area ratio, we have it. We now can find out the length ratio by square root it. And then after you find the length ratio, you can find out the radius of the smaller sphere and then put in the volume of sphere formula. You will have the answer. Or you can use method 2. Method 2 is when you have the area ratio, find out the volume ratio. So you have the volume ratio, the length ratio to the power 3. And then use this ratio to times the larger volume, the volume of the larger sphere. And then you will have the smaller one because their ratio is 8:27. Okay, 8/27. Okay, part B. Copy the two sphere are melted and recast. So volume the same, always remember that. And then it's now turned to two circular cones. We have one cone here, another cone here. For cone A, we have the height and base 10 and 6, so label it on the graph. And this one, we don't have the height, we only know the base radius is 12. The question asks if they are similar. So as I say, when we want to know if they are similar figure or not, we need to compare all the length or the ratio of length compared with the ratio of volume. So now, because we already have two radius, we already know the length ratio, we find out the height, we can compare. Okay, so what information do we have? Is the volume the same? So the original volume should be equals to the volume of the new volume of these two adding up together. So original volume, we have the two sphere. So we only have the smaller one. We need to plus the larger one. So for the smaller one is 288 pi. We already calculated. And for the larger one, as the radius is 9, so we put in the sphere volume formula equals to the new volume. New volume is 2 cones, so 1/3 times the radius square times the height. Okay, so here is base area. So r square pi, pi is here as well. R square pi times the height. The height here is an unknown. So actually we need to let h be the height of, okay, remember to write the assumption sentence, okay? So now we calculated, cancel all the pi at the first step, and then we can calculate h equals to this one. So the ratio of height is 10/95/4, which is not equals to the ratio of radius. The radius is 1:2, right? As it says, the radius of base should be 1:2. Okay? So this one should be in part B. Okay, so they are not similar. 2023's paper, the sentence is very short, and then it gives a cone to you, and the base radius is 14 cm, the curved surface area is 700 pi. So now you need to find the height of the circular cone. Okay, so first, what is the formula of finding the curved surface area? It's L pi, right? So we first find out the L. And then we know that for finding the L, we can find the height by Pythagorean. So 14 square plus h square equals to 50 square. Because the slant height is this one, right? And then the height is this one, the radius is this one. So it's Pythagorean. So we find out the height equals to 48. And then the circular cone here divide into one smaller cone and a first term, okay, and a first term. The curved surface area of y, which is the first term, is 15 times the curved surface area of x. So first, this is the area ratio, right? Area ratio. But be careful of it. Can we directly change this 1 to 15 and then turn to the volume ratio or length ratio? Let's say square root it. Can we? No, we can't. Why? Because these two are not similar. The first term and the cone are not similar. So keep in mind that what is similar is the smaller cone and the larger cone. So what is the ratio between the smaller cone and the larger cone? What is the curved surface area ratio? It should be 1 to 15 plus this one here, okay? So the largest cone should have 16 in the ratio, right? Should have 16 in the ratio because 1 plus 15. So 1 to 16. What we're doing here is finding the area ratio of the smaller cone to the largest cone, because only similar shape can use the property of changing the ratio to volume or length, okay? Only similar figures have the property of changing the volume ratio, area ratio, and length ratio. So 1 to 16, now we can change into the volume ratio. How? By first square root it, and then actually square root is to find the length ratio. We just skip a step here. Find the length ratio 1 to 4, and then to cube it, we have 1 to 64. So we find out the volume of the smaller cone to the larger cone will be 1 to 64, okay? So now we need the volume of y. Volume of y, it means the volume of the first term, So it's the larger cone minus the smaller cone, right? Okay, so first we need to find out the total volume, okay? Total volume, the larger cone, what is the volume of the larger cone? So the larger cone in part A, we already have the height and we have the base radius. So base area is a circle, right? Times 1/3 times height. We have the larger cone volume as this one, and then we time the ratio. The ratio of the smaller cone should be the larger cone times 1/64, and as we say, larger cone minus smaller cone equals to the first term, right? Equals to the first term. So largest minus the tip here equals to the first term down there, okay? So we use the larger cone minus smaller cone divided by the ratio, and then we have the first term's volume. Okay, B2 is saying that y is melted and recast into two identical spheres. Find the diameter. Everyone, be careful, diameter. So first, the volume unchanged, as I said many times, the volume unchanged. So new volume equals to the original volume. Original volume should be this one, because now we are melting y, okay? So what you calculate in B1 equals to the new volume of the sphere. So let R be the radius of the sphere, and actually what they want you to do here is memorize the sphere formula, right? Here we have the formula and then times 2 because it's two identical, okay? And then we solve out, R equals to 10.5. And then remember we are finding the diameter. You need to times 2, okay? You need to times 2. So final answer is 21. 2024's paper. In this question, we have a pyramid. So it has a square base, and the height of this pyramid is 24 cm. It now cut into first term x and the pyramid y. So this pyramids here are cut into a smaller pyramids and the first term. And given that the height of y is 18, so it means that the x have the height 6. Okay. So first, find the volume of x. Now you have the length ratio, you have the side, you have the side provided to you, which is 64, and this one is very easy to find. So 18/24 should be equals to the side of smaller pyramid to the larger pyramid. Okay, so in method 2 we use the ratio and the side of the smaller pyramids. Finding the side of smaller pyramids, you can directly find the volume of the larger one minus the smaller one. Okay, so for square pyramids, we first find out the base area. For square is the side square times the height times 1/3 minus the smaller pyramids with height 18 and then base area times 1/3. Okay, we have those numbers here. Or you can use method 1. Method 1 is using the ratio. The length ratio is this one, 3 to 4. So the volume ratio should be 3 to 4 cubed, right? So we have 27 to 64. So the volume of x should be the largest one, the largest pyramid, which is this one, minus the smaller one. Minus the smaller one, we don't need to calculate the size of the smaller one. We can directly find it by using the ratio. The largest one times the ratio we just find out should be the volume of the smaller one, and you have this number as well. So method 1, method 2. I think method 2 is easier to understand. Okay. Okay, part B. Now we have another pyramid here. The base is square again, and then it cut into frustum and pyramids, just like what happened to this one, okay? Just like what happened to this one. Now, we know the height and the total surface area of Z are 3 and 960. So it means that another pyramid here cut into a smaller pyramid and the frustum. The frustum here is 3. Surface area is 960. Now asking you, are X and Z similar? It means that two frustum here, are they similar? So what you need to do is compare the ratio, right? Their length ratio, you already have it. The length ratio here is 6, here is 3. So 3 to 6, 1 to 2. This is their length ratio. Now, they give the surface area to you. So you can use the surface area to find out the side, the side. So that you can compare two length ratio, are they the same? Or you just directly compare the area ratio, because now you have the surface area, right? Okay, so for Z, you have the surface area. For X here, you don't have the surface area. So you need to find it out. How to find out? Square pyramid, we have the base like this, and then we have 4 lateral face. So basically, when it cut to us frustum, it will have this one and this one under. So we have the upper base, lower base, 4 lateral face, and 4 lateral face here. So 6 faces. We have 6 faces. The first two very easy. The upper base should be 48 square, because we already calculate using method 2. If you're not using method 2, you need to find out by using the ratio, okay? By using the ratio. So 48 is the upper base, and then the lower base should be 64 square, okay? 64 square. Find the square, the area of square. And then the 4 lateral trapezium is very hard to find, because first you need to find the largest triangle, and then minus the smaller triangle, you will have the trapezium here, okay? You will have the trapezium here. Okay, so how we find it? First, the larger triangle. The larger triangle have the base 64, and then time the height. Be aware of it, just like what we do to cone. The height of this lateral triangle is not the height of the pyramid. The pyramid have height 24. This one you need to find out by Pythagoras. So 24 square plus 32 square. But what is 32? Because in the triangle lateral face, we cut into half. So the side 64 here need to divide by 2, which is 32, and then we are finding the height of the triangle face, and this one is the height of pyramids. Okay, so Pythagoras. So be careful when you're dealing with the surface area of pyramids and cone. You need to find the height of the face, not the height of the pyramid or the cone. Okay. And then divide by 2, why? Because base times height divided by 2 is the area of triangle, minus the largest triangle minus the smaller triangle, right? So for the smaller triangle, you also need to find the height of lateral face. 18 is the height, and then 24 is the half of its side. And then by square root, you will have the height of the lateral face times the base times height divided by 2. Okay, so now you finish the process of calculating the trapezium. Okay, times 4. Okay, so someone asked me that can I directly use the formula of trapezium, upper base plus lower base times height divided by 2? Yes, you can, but the height, you also need to use this to find, right? The height of this trapezium will be the largest side, will be the largest height, minus the smaller height to have this height here. So you need this 2 Pythagoras anyways, okay? Times 4, because we have 4 lateral face. And then you just solve it by calculator. You will have the surface area of this one. So you compare the surface area ratio, this one to this one, X to Z, is 1 to 9, but the height ratio is 1 to 2, 1 to 2. When you square root the area ratio, you will have 1 to 3, which is not the same with the height ratio, the length ratio, right? The length ratio. Okay, so they are not similar. They are not similar. 2014 paper, I recommend everyone to try read the question. You can see the graph. It's very complicated. Okay, now what we have is a vessel, and then the height is 96 and the radius is 72 cm. So basically the largest one is the vessel, and then it cut the lowest part. So cut the lowest part, this part here, it represents in dot line. And then the height of the vessel is 60 cm. Now the water depth is 28 cm. So this one makes the water very difficult to look at. How about we draw it by ourselves? Now we have a vessel, it's in frustum, and then it cut the lowest part. The waters here will be in the, you can see it's another fraction here, actually, it's another fraction here. And then this is the water, the amount of water. So first question asking you, find the area of wet. Wet means the surface contact with the water. So basically it's finding the curved surface area of this frustum here, okay, contacting the water. And then in terms of pi. Okay, so some revision for cone. How we calculate the curved surface area is using pi r l. L here is the slant height. So remember that you need to find the slant height. You don't have the slant height here, okay? Think about this. Now you want to find the middle frustum. So you only have the radius of the largest one. It means that first you need to find the radius of this one, of the middle one, middle frustum. And then in order to minus the smaller cone here, you need the radius of this one. How we find the radius? Always remember that when we have encountered those frustum questions, it's always similar triangle. Because they are from one cone, right? Actually, they are from one triangle here, and then you're cutting them. So it's AAA, right? It's always AAA, so they are always similar. So now, you have 72 here. How can you use 72 to find the radius of the smaller frustum and the smaller cone? You can use the height to help, because you have the length ratio through the height. Okay, 36 by 96 minus 60 here, you can calculate this one. Okay, so we use the ratios to help us find out the radius. Okay, the ratios of the radius should be the smaller, the radius of the frustum over the largest cone. So R over 72 equals to the height of this two, the smaller cone plus the frustum over the largest cone. Always remember that what is similar is not the frustum, the similar shape, is the cone. So when you thinking about those questions, you need to think in the concept of cone. Okay, always thinking which cone minus which one can get the frustum. Okay, so we know that actually the middle cone here minus the smaller cone there, you can calculate the frustum. So after you calculate, you will find out the middle cone will have the radius 48. And then for the smaller cone, same methods here, find out the height ratio, and you will have the same ratio with the radius, and then the radius is 27. Okay, by this, finding out the radius, you already have this, you already have the height. Now you are finding the curved surface area, So you need the slant height. Okay, we can just find it in the one equation. This equation using Pythagorean theory, because right angles here. Okay, 48 square. Here 48 square, and then 64 square root, we will have the slant height times pi times r is the curved surface area of the middle cone, and then minus the smaller one is same the Pythagorean here, and then the pi, the radius, and you just calculate with your calculator, and we need to keep it in terms of pi, so you keep it in terms of pi. This is the final answer. Okay, this is method 1. For method 2, you can use ratio to help. So in this case, you don't need to find out the radius. Because for finding out radius, you need to find one by one, right? So you can directly use the ratio, but I think in concept, this one, method 2 here, is more complicated. So when you can directly find the radius, why don't you just directly find the radius? Okay, so method 2 here, we first find out the entire cone surface area. So the largest one, we find out the whole curved surface area here. And then we minus this part. And then we minus this part, and then we will have it. Okay, first, when we have the entire cone, we need to know the ratio of the area, surface area, right? So using the ratio of their length ratio, and then do some simplify. And then length ratio square is the area ratio. So square those numbers. So it will equal to the area ratio. So the area ratio is in this ratio. This is the largest cone, middle cone. Remember, it's a cone, it's not the fraction. And then this is the smaller cone, okay? So it should be this one to this one to the smaller one, okay? And then we can use the entire one times the middle cone times the ratio of middle cone. Then you can find the surface area of the middle cone, okay? Of the middle cone. And then we minus the lower part, the smaller cone, the surface area of the smaller cone. What we have will be the first term, right? So we minus the entire one times the ratio of the smaller one, okay? So after you minus it, you will get the same answers here. Of course, here you can say it's a common factor. You can take it out. Okay, for B, the volume of water. So now, B finding the volume. We need to use the 1/3 formula to find it. Remember to take a lot of the unit, okay? Always take a lot of the unit. If it changed, we it used to be in cm, right? Now it's in m's cube. So you need to change your unit at the end, okay? Okay, in this situation, actually we are finding the volume of the first term. We are finding the amount of water. Actually, it's finding the volume of the first term, okay? The middle first term. So how to find is still the largest cone minus the smaller cone. You will have the middle part. Okay, in this case, if you are using method 1, if you are using this method 1, you already find all the radius, right? And the height, you have all the heights here. So you can directly do it without using the ratio. So I think this one will be easier for you. How to find the volume? 1/3 and then time the base area 48 square pi, the circle area, right? Time the height 64, and then minus the smaller one 1/3 27 pi 27 square pi times the height, and then you can calculate this results here. And remember that you need to change the unit. How you change cm to m cube? It's cube. So for 100 cm equals to 1 meter. So when it is square, this one will be square. So it's 10,000 cm square equals to 1 m square. When it turns to cube, then it will be 100 to the power 3 cm cube equals to 1 meter cube. Okay, so it's 100,000 here. Okay, after you divide it, it's 0.127 m cube. So it's larger than 0.1 m cube. So we agree with it. It did more than, right? Greater than, okay? Okay, 2020's question, it looks very similar to 2014's question. Okay, so you can try this two at the same time. Now, first you have a cone.
Have the height and the base radius, and then it's cut into 3 parts. It means that it creates 2 more similar cones, okay? The height of the 3 parts are equal. So the height is 36, it cut into 3 parts equals so 12, 12, 12, with the base radius 15. Find the volume of the middle part. So volume of the middle part. When we think about similar shape, right? We always need to think in the concept of cone. So this one is the smaller one, this one is the middle cone, this one is the largest cone. So when we want to find middle part, actually we can find the upper 2. So this middle cone here minus the upper cone here will have the volume of the middle one, right? But now we only have the base radius of the largest one, Can you find this and this? We first let the unknowns to them. So the radius of upper one is RU. So the median of the middle one, RM. So what you have here is they are similar. You know it because they've cut from the same cone, right? They are not separate cone. So they must be similar. Their length ratio are in the same ratio. So you have the height as the clue of length ratio. You can find the radius 1/3 minus the upper part, the smallest part, and then you have 700 pi cm cube, okay? So this is method 1. Method 1, we find out the radius first and then put in the formula. So we have a quicker method, but it requires more concept of similar ratio, which you need to be very familiar with it. So I think most of you can stick to the first method, it's okay, both have full mark. Okay, method 2 here, we first calculate the total one, the largest one. 1/3, 15 square pi, the base area of this one, and then time the height. And then we time the ratio of the middle one. The middle one should be half the length ratio 2 to 3, right? 2 to 3 as we found here. And then we cube it. This ratio here now turns to the volume ratio. It turns to volume ratio. So volume ratio times the total one, you can find out the volume of the middle cone, not the middle phosphate, okay? Not the middle frustum, it's middle cone. And then minus the total one, still the same equation here, times the ratio of the smaller cone, times the ratio of smaller cone 1/3 cube, because volume, it turns to cube, 1/3 is the length ratio. And then you can see this is the common factor, right? Common factor. So we take it out, common factor, and then what we left here is the ratios. So you use your calculator to calculate, and then the ratio times this one, we have 700 pi as well. So this one can do in one equation. It really up to you, okay? It really up to you. If you think you can understand this one and you can apply it, you can use this one. And then B, the curved surface area of the middle part. So now, if you're using method 1, you already have all the radius, all the height. So you just put in the formula and you can find it. So the radius, we already have it, pi, and this is the slant height. Always remember you need the slant height. So for slant height, you need to use Pythagorean to find it. This one as well, Pythagorean of the smaller cone. You need to minus the surface area of the smaller cone. So minus it. It's still slant height, radius pi, and you will have this one. Or you can use method 2. Because if you use method 2 here, actually you haven't found out the radius of the middle part and the smaller cone, right? So you can in part B use the concept of radius. In part B you can use the concept of ratio again. So find out the total of the largest cone's surface area, curved surface area. So pi r slant height times its ratio, times the first one is the ratio of the middle one, and this time we only need to square it. And then minus the smaller one, the ratio is 1/3, and square it.